In the summer of 1940, a man named K.T. Keller received a telephone call that would change the course of the war. Keller was the president of the Chrysler Corporation, a man who had spent his career building automobiles in Detroit, a man who understood gears, crankshafts, assembly lines, and the mathematics of mass production. The call came from William Knudsen, the former president of General Motors, who had been recruited by President Roosevelt to organize American industry for war. Knudsen asked Keller a simple question: could Chrysler build tanks? Keller paused. He had never built a tank. He had never seen the inside of one. His factories made sedans and coupes, vehicles designed to carry families to church on Sunday and salesmen to appointments on Monday. A tank was a different species of machine entirely, a 30-ton fortress of steel plate, powered by an engine operating under conditions no automobile engine would survive, rolling on tracks instead of tires, carrying a cannon that recoiled with enough force to crack the frame of a Chrysler Imperial. The gap between a car and a tank was the gap between a canoe and a battleship. "I don't know," Keller said. "I've never seen one of these things." He traveled to the Rock Island Arsenal in Illinois, where the Army showed him the M2A1 medium tank, a primitive, awkward machine that was already obsolete by European standards. The French had just fallen. The Wehrmacht's panzers had crossed the Meuse and driven to the English Channel in 6 weeks, proving that armored warfare was not theory but reality, and that the nation that could not build tanks fast enough would lose. The American Army had fewer tanks than the New York City Police Department had patrol cars. The situation was not desperate. It was worse than desperate. It was non-existent. Keller went back to Detroit. He gathered a secret team of engineers. Within 1 month, they had estimated the cost, designed the production line, and located a site, 113 acres of farmland in Warren Township, Michigan, 17 miles from downtown Detroit. Ground was broken in September 1940. The walls were not finished when the first tank rolled off the line. They brought a steam locomotive into the building to heat the workers during the Michigan winter because the heating system had not yet been installed. By April 1941, the first M3 Lee medium tank was delivered. The factory was still being built around the workers who were building the tanks. This was the Detroit Arsenal Tank Plant, and it would become the birthplace of American armored warfare. But the tanks it produced were only as good as the systems inside them, and the system that mattered most, the one that determined whether a 30-ton machine could move, turn, climb, and fight, was the one nobody talked about: the transmission. Every argument about tanks in the Second World War eventually becomes an argument about guns and armor. How thick was the steel? How far could the shell penetrate? Could a Sherman's 75mm gun punch through a Tiger's front plate at 1,000 yards? The answer to that last question was no, and that answer has dominated the popular understanding of American armor for 80 years. The Sherman was undergunned. The Sherman was underarmored. The Sherman was a death trap. You have heard this story. Parts of it are true. Most of it misses the point. The point is this: a tank that cannot move is not a tank, it is a pillbox. A tank whose transmission breaks on a road march is not a weapon, it is a roadblock for the tanks behind it. A tank that can be driven by a farm boy from Iowa with 3 weeks of training and maintained by a mechanic who learned his trade on Chevrolets is a weapon that can be deployed by the tens of thousands, on every front, in every condition, and replaced faster than the enemy can destroy it. The war was not won by the tank with the thickest armor. It was won by the tank that showed up. And showing up in a war that stretched from the beaches of Normandy to the islands of the Pacific, from the deserts of North Africa to the frozen forests of the Ardennes, meant driving thousands of miles over roads that were bombed into rubble, through mud that swallowed vehicles to their axles, in temperatures that ranged from 50 degrees below zero to 120 above. Showing up meant that the transmission, the gearbox, the differential, the final drives, the clutch, the shift linkage had to work. Not sometimes, not usually, always. The Sherman's transmission worked. The transmission that went into the M3 Lee and then into every variant of the M4 Sherman was a 5-speed manual gearbox with synchromesh on gears 2 through 5. First gear and reverse were unsynchronized, a deliberate choice, since first was essentially a crawler gear used only on the steepest grades, and reverse was used at such low speeds that synchronization was unnecessary. To understand what synchromesh meant for a tank crew, you need to understand what driving a tank without it was like. In a tank without synchromesh, and this included most German tanks for much of the war, shifting gears required a technique called double clutching. The driver pressed the clutch, moved the shifter out of the current gear into neutral, released the clutch, blipped the throttle to match the engine speed to the new gear, pressed the clutch again, and moved the shifter into the new gear. This was a skill that required practice, timing, and a feel for the engine's speed. It was difficult in a car. In a tank, where the gears were massive, the shift linkage was heavy, the clutch required the full force of a man's leg, and the entire vehicle was vibrating, lurching, and being shot at, double clutching was an athletic event performed under combat stress. A missed shift in a Panther or a Tiger did not merely cause a grinding noise. The forces involved were enormous. The gears were steel, the shafts were thick as a man's forearm, and the rotational momentum of the drivetrain was measured in hundreds of foot-pounds. A botched shift could strip teeth from a gear. It could crack a synchro hub. It could jam the gearbox in a position between gears when nothing engaged and the tank simply stopped moving. In combat, on a road in France or a field in Russia, a stopped tank was a dead tank. German crews knew this. Their training manuals devoted entire sections to the art of shifting, treating it as a skill as critical as gunnery. The Sherman synchromesh eliminated the problem. The synchronizer cones, brass rings inside the gearbox that matched the speed of the gear to the speed of the shaft before engagement, did the double clutching automatically, mechanically, silently. The driver pressed the clutch once, moved the stick to the new gear, and released the clutch. It was exactly like driving an American automobile of the 1930s. If you could drive a Ford to the grocery store, you could drive a Sherman to Berlin. This was not an accident. It was a philosophy. The American military, facing the need to train millions of men in months rather than years, designed its equipment to be operated by the average young American male, a farm boy, a factory worker, a gas station attendant, with minimal specialized training. The Sherman was not designed for expert tankers, it was designed for everyone, and the transmission was the heart of that design philosophy. It took the most complex, most failure-prone, most skill-dependent mechanical act in tank operation, shifting gears under stress, and made it idiot-proof. The Sherman's transmission was manufactured by 6 companies: Buick, Caterpillar Tractor, the Chrysler Defense Arsenal, Ford Motor Company, Iowa Transmission, and Reed Roller Gear Company. Several sources suggest Caterpillar was the original designer, drawing on decades of experience building transmissions for bulldozers and heavy earth-moving equipment, machines that, like tanks, needed to move enormous weight over unforgiving terrain at low speeds with absolute reliability. But the genius of the production system was that parts from any manufacturer worked with parts from any other. A Buick transmission case could accept Ford gears. A Caterpillar differential could bolt to a Chrysler final drive housing. The interchangeability was total. This was the American manufacturing doctrine at its purest: standardized drawings, standardized tolerances, standardized materials, standardized inspection. Any Sherman anywhere in the world could be repaired with parts from any other Sherman, regardless of where or by whom the parts had been made. The contrast with German practice was stark. German tank transmissions were manufactured to specifications that were, in many cases, tighter than American standards. German engineering was brilliant, German metallurgy was excellent, but German manufacturing was not designed for interchangeability at the scale America required. Parts were often fitted by hand. Transmissions from one factory did not always match components from another. In the field, German mechanics faced the nightmare of discovering that a replacement gearbox shipped from a different production facility did not quite fit the tank it was intended for. American mechanics faced no such problem. A transmission was a transmission. It bolted in, it worked. The entire Sherman powertrain, transmission, differential, and final drives was designed as a removable unit. A trained crew could pull the entire assembly from the front of the tank and replace it with a fresh unit in the field. The powertrain shared a common oil supply of 152 quarts between the transmission, the differential, and the final drives. The only routine maintenance the crew needed to perform was adjusting the shift linkage and changing the fluid. Everything else was designed to last until the tank was either destroyed or sent to a depot for overhaul. The oil capacity alone tells a story. 152 quarts. A modern automobile uses 10 or 15. The Sherman's transmission lived in a bath of lubricant deep enough to drown a small dog. Everything was overbuilt, over-oiled, over-engineered for durability. The gears were steel, the case was cast iron, and the entire assembly was designed with margins of safety that reflected the American industrial philosophy. Make it strong enough that it won't break, then make it a little stronger because a soldier's life depends on it. The Panther tank, the Panzerkampfwagen 5, is often described as the best medium tank of the war. Its 75mm high-velocity gun could destroy any Allied tank at ranges exceeding 1,000 yards. Its sloped frontal armor was effectively impenetrable to the Sherman's 75mm gun. Its combination of firepower, protection, and mobility was, on paper, superior to anything the Allies fielded until the final months of the war. On paper. On the road, the Panther was a catastrophe. The Panther's transmission was a ZF AK-7200, a 7-speed synchromesh gearbox that was, mechanically, a fine piece of engineering. The problem was that it was mated to a 44-ton vehicle powered by a 700-horsepower engine through a drivetrain that was fundamentally overstressed. The final drives, the gear assemblies that transferred power from the transmission to the drive sprockets that turned the tracks, were the chronic failure point. They wore out in a few hundred kilometers. In some units, Panthers were being pulled from service for final drive replacement after as little as 150 kilometers of road marching. 150 kilometers! That is less than the distance from Paris to Rouen. A Panther could not drive from one French city to the next without breaking down. The Tiger I was worse. Its transmission, also a well-engineered unit, was connected to a 63-ton vehicle that imposed loads the drivetrain could barely handle. Transmission failures were so common that every Tiger company required a maintenance tail, a fleet of recovery vehicles, mechanics, and spare parts that was equivalent in size and cost to an entire battalion of Panzer IVs. One Tiger company consumed the same logistical resources as a full battalion of medium tanks. The German army was, in effect, trading 3 usable tanks for every 1 Tiger it deployed, because the support infrastructure required to keep the Tiger running ate the resources that could have fielded 3 Panzer IVs instead. The problem was not just mechanical, it was strategic. Every Panther that broke down on a road march was a Panther that never reached the battlefield. Every Tiger that needed a new transmission was a Tiger that sat in a repair depot for days or weeks while mechanics worked to fix a problem that the tank's own weight had created. During the Ardennes offensive of December 1944, the last great German armored thrust of the war, more Panthers were lost to mechanical failure than to Allied action. The tanks that were supposed to break through the Allied lines broke down before they reached them. Roads in the Ardennes were littered with abandoned Panthers, their crews standing beside them in the snow, waiting for recovery vehicles that were themselves broken down somewhere behind them. The Panther did not lose to the Sherman in a head-to-head gunnery duel. The Sherman could not win that fight, and it rarely tried. The Panther lost to the Sherman because the Sherman showed up, and the Panther did not. The Sherman was there, on the road, in the village, on the ridge, ready to fight because its transmission worked, because its engine ran, because its tracks did not throw themselves off the sprockets, because every mechanical system in the vehicle had been designed by people who built trucks and tractors and automobiles, machines that were expected to work every single day. The Sherman's transmission never had these problems. It was not more advanced than the German transmissions. In some respects, it was less sophisticated. It was a 5-speed where the Germans used 7. It used brass synchronizers where the Germans used more complex designs. But it was built with margins. It was designed for a tank that weighed 30 tons, not 44 or 63. And it was built by companies that had spent decades manufacturing automotive transmissions for a market that punished unreliability with lost sales. If a Buick owner's transmission failed at 30,000 miles, he bought a Ford. That competitive pressure, the invisible hand of the American consumer market, had produced transmissions that were, by the early 1940s, among the most reliable mechanical devices on Earth. The Germans built transmissions for tanks. The Americans built automotive transmissions and put them in tanks. The difference was not in engineering brilliance, the difference was in philosophy. And the philosophy that built for reliability rather than for perfection won the war. To understand what the Sherman's transmission meant in human terms, you need to sit in the driver's seat. The driver of a Sherman sat in the left front of the hull, low, with the massive cast steel transmission housing directly in front of him and the propeller shaft running beneath his feet from the engine at the rear. His seat was adjustable. His controls were simple: a clutch pedal on the left, a brake pedal in the center, an accelerator on the right, two steering levers that operated brakes on the left and right tracks, and the shift lever mounted to the left of the transmission. The shift pattern was a traditional H-gate, identical to the manual transmission in a contemporary American automobile. Second gear was up and to the left. Third was down and to the left. Fourth was up and to the right. Fifth, the overdrive gear, used only on good roads at maximum speed, was down and to the right. First gear, the crawler, required pulling the lever hard to the left and up against a detent spring. Reverse was below first. The feel of the shift was solid, not smooth in the way a modern car is smooth. There was no power assist, and the gears were heavy, but positive. The synchronizers bit with a mechanical certainty that told the driver the gear was engaged. There was no guesswork. There was no grinding. There was a satisfying clunk as the dogs meshed and the gear locked in. A driver in combat, his adrenaline surging, his hands shaking, his vision narrowed to the slit of his periscope, could shift gears by feel alone. He did not need to look at the lever. He did not need to think about engine speed. He pressed the clutch, moved the stick, and the transmission did the rest. Compare this with the experience of a Panther driver. The Panther's transmission was located in the front of the hull, like the Sherman's, but the shift required more force. The clutch was heavier. And if the driver, a 19-year-old conscript who had been trained for weeks rather than months, missed a shift under stress, the consequences could be catastrophic. A jammed gear, a stripped tooth, a tank that would not move, sitting in the open, a target for every anti-tank gun and tank destroyer in the area. The American Army trained its tank drivers in weeks. They arrived from farms and factories knowing how to drive cars and trucks. The Sherman's controls were familiar. The learning curve was gentle. By the time a replacement driver reached his unit, he could operate the tank competently, if not expertly. The German Army needed its tank drivers to be skilled mechanics who understood the temperament of their machines. The Panther demanded respect. The Sherman demanded only competence. In the mathematics of a global war, where replacement crews were being shipped to the front by the thousands, where training time was measured in weeks, where the average life expectancy of a tank in combat was measured in days, the transmission that any American boy could operate was worth more than the transmission that only a trained expert could master. Chrysler's Detroit Arsenal tank plant was the most productive tank factory in American history. It produced over 22,000 tanks during the war, roughly a quarter of all American tank production. In December 1942, with only 5,000 workers, the plant produced 897 Sherman tanks in a single month, a record that was never broken. But the number that astonished the government accountants was not the production rate. It was the refund. Chrysler's engineers became so efficient at building Shermans that the per-unit cost dropped below the contract price. Chrysler wrote checks back to the United States government totaling millions of dollars in refunds and price reductions in 1940s dollars. They were returning money because they had figured out how to build the tanks cheaper than they had promised. No German company ever returned money to the Reich because they had become too efficient. No German factory ever produced tanks faster than the government could pay for them. The German industrial model was built on precision, on engineering excellence, on the conviction that a superior machine would overcome a numerical disadvantage. The American model was built on volume, on standardization, on the conviction that the best machine is the one you have 10,000 of when you need them. K.T. Keller, the man who had never seen a tank when the phone rang, presided over this transformation. His Chrysler executives worked for $5 a year. The factory walls were 3 feet of concrete designed to withstand aerial bombing. The production line operated 24 hours a day. The workers, thousands of them women, filling the positions left empty by men at war, learned to weld hull plates and assemble transmissions and test engines with a speed and precision that would have been unimaginable in peacetime. The Sherman's transmission proved itself in every theater of the war, in conditions that ranged from the absurd to the apocalyptic. In North Africa, where fine sand infiltrated every mechanical joint and temperatures baked metal until touching a hull plate with bare skin raised blisters, the Sherman's powertrain endured. Sand is the enemy of all mechanical systems. It enters through seals, embeds itself in lubricant, and grinds against bearing surfaces with a patience no engineer can defeat. The Sherman's answer was volume. Volume of oil, volume of clearance, volume of material between moving parts in the world trying to destroy them. The 152 quarts of oil in the powertrain acted as a reservoir that diluted contamination. Sand particles that would have seized a German transmission with tighter tolerances simply circulated through the Sherman's more forgiving system, wearing it gradually rather than killing it suddenly. In Italy, where narrow mountain roads and medieval stone bridges tested steering and braking on gradients that would stop a civilian truck, the Sherman climbed. The first gear, the granny gear at 7.56 to 1, gave the tank a crawling speed of 1 to 2 miles per hour with enormous torque multiplication. Italian mountain roads, slick with rain, barely wider than the tank itself, with sheer drops on one side and stone walls on the other, demanded precise low-speed control that only a well-synchronized transmission could deliver. Many Italian roads could not support a Tiger at all. The bridges collapsed under its weight, the roads crumbled beneath its tracks. The Sherman went where the Tiger could not because it was light enough for the infrastructure and reliable enough for the distance. In Normandy, the Bocage country presented a different torture. The ancient hedgerows of northern France, dense walls of earth, roots, and centuries of growth dividing the landscape into thousands of tiny enclosed fields, required constant low-speed maneuvering. Tanks pushed through hedgerows, reversed out of dead ends, turned in spaces barely larger than the vehicle itself, then accelerated across open ground before the next hedgerow provided cover. The transmission shifted constantly, first, second, reverse, first again, in conditions that maximized wear on the clutch and synchronizers. The Sherman's components held. Crews welded steel prongs cut from German beach obstacles onto the front hull to tear through the hedgerow roots, but the transmission needed no modification at all. It simply worked, shift after shift, field after field, hedgerow after hedgerow, from June to August and beyond. The British, who received thousands of Shermans under Lend-Lease, conducted long-distance reliability trials in 1943, comparing Shermans to British-built Cromwell and Centaur tanks. The officer commanding the tests wrote that the Shermans were utterly reliable and appeared so infinitely superior in reliability with a minimum of maintenance that other considerations were completely overweighed. This was a British officer complimenting an American machine, a sentence that required significant provocation to produce. Soviet tankers of the 6th Guards Tank Army, who received Sherman M4A2 diesels through Lend-Lease, reported operational lifespans of 2,000 to 2,500 kilometers, comparable to the T-34, which the Soviets considered their benchmark of armored reliability. The Soviets were not sentimental about equipment. If a machine did not perform, they said so in terms that required no translation. That they rated the Sherman alongside their own T-34 was the highest compliment the powertrain could have received from the most demanding operators on the planet. The contrast with German experience in those same months was devastating. By late 1944, a Panther fresh from the factory might cover 150 kilometers before its final drives demanded replacement. 150 kilometers is less than the distance from Paris to Rouen. A Panther could not reliably drive from one French city to the next without breaking down. During the Ardennes Offensive of December 1944, Hitler's last great armored gamble, more Panthers were lost to mechanical failure on the approach march than to Allied fire during the battle. Roads in the Ardennes were littered with abandoned German armor, their crews standing beside them in the snow, waiting for recovery vehicles that were themselves broken somewhere behind them. The offensive that was supposed to split the Allied armies was strangled not by American firepower, but by German unreliability. American crews, meanwhile, drove their Shermans for thousands of miles across France, Belgium, and Germany with nothing more than routine maintenance. They adjusted the shift linkage when it got sloppy. They changed the oil when the manual said to. They listened to the transmission the way a good mechanic listens to any engine, for a whine that meant a bearing was wearing, a clunk that meant a synchro was thinning, a vibration that meant something was not right. And when a powertrain finally did fail, when a bearing wore through or a gear lost a tooth after thousands of miles, they unbolted the entire assembly from the front hull, slid it out on guide rails, slid a fresh unit in from the depot, connected the propeller shaft, and were rolling again within hours, not days. Hours. This was the decisive advantage. Not the ability to win a one-on-one gunnery duel with a Tiger. The Sherman could rarely do that, and it was not designed to. The decisive advantage was the ability to be there, reliably, consistently, in numbers that overwhelmed, day after day, mile after mile, in every condition the war could produce. The Sherman's transmission was not a weapon anyone celebrated. No war correspondent wrote about it, no general mentioned it in his memoirs, no Hollywood film showed a crew changing a gearbox in the rain at 3 in the morning. The transmission was invisible in the way that breathing is invisible. You only notice it when it stops. But the men who drove the tanks knew. They knew that the stick shifted smoothly, that the gears engaged without protest, that the tank responded to the driver's hand the way a good truck responded. Not with the precision of a sports car, but with the solid, predictable, forgiving reliability of a machine built to work every day under hard conditions and never complain. They knew that when the order came to advance, the tank would advance. When the order came to reverse out of an ambush, the transmission would find reverse without jamming. When they needed to climb a hill in first gear and then accelerate across open ground in fourth, the shift happened without drama. This was not excitement. This was not glamour. This was the American way of war. Not the best on any single axis, but the best on every axis that mattered. Reliability, producibility, maintainability, trainability. The Sherman's transmission embodied all four. It was reliable enough to cross a continent. It could be produced by 6 different companies from interchangeable parts. It could be maintained by a mechanic who had learned his trade on automobiles. It could be operated by a driver trained in weeks rather than months. After the war, German engineers studied captured Shermans with the professional curiosity of men who had spent 5 years fighting them. They were not impressed by the armor. They were not impressed by the gun, but the transmission gave them pause. They had expected crude American manufacturing, sloppy tolerances, rough machining, quantity over quality. What they found was something different. The Sherman's transmission was not crude, it was simple. Every component was machined to tolerances that were adequate, not excessive, tight enough to function perfectly, loose enough to be manufactured by the millions. The gear teeth were well cut, the bearings were well seated, the synchronizers were effective and durable. The entire assembly was designed not to impress an engineer, but to work for a soldier. The German engineering tradition valued perfection. The American tradition valued sufficiency. The German approach produced transmissions that were, at the moment of manufacture, possibly superior in precision and finish. The American approach produced transmissions that were, across the entire span of their operational life, vastly more reliable, vastly more replaceable, and vastly more numerous. The answer was delivered in the wreckage of the German war machine, 100 good ones, every time. The Detroit Arsenal tank plant survived the war. It produced M47 Pattons during Korea, M60s during the Cold War, and M1 Abrams tanks into the 1980s before Chrysler sold the defense division to General Dynamics. The plant was a continuous thread connecting the Sherman of 1942 to the Abrams of 1982. 4 decades of American armored vehicle production, all of it rooted in K.T. Keller's decision to answer a phone call and say yes to a machine he had never seen. The Sherman's transmission design, with its synchromesh gearing and its front drive layout, influenced every American armored vehicle that followed. The principle it embodied, that military equipment should be designed for the average operator and the average mechanic, not for the expert, became doctrine. The M1 Abrams has an automatic transmission, eliminating the human operator from the shifting process entirely. But the philosophy is the same. Make it simple, make it reliable, make it maintainable by the soldier who uses it. 50,000 Shermans were built. They served in the armies of dozens of nations. They fought in Korea, in the Arab-Israeli wars, in South America, in Asia. Some remained in service into the 1970s, 3 decades after they rolled off the assembly lines of Chrysler and Ford and Fisher and the locomotive companies and the steel car companies that had never built a tank before the war and never built one after. The transmissions in those tanks, the 5-speed synchromesh gearboxes designed by tractor companies and built by automobile makers, outlasted the empires they fought for.
There is a photograph taken somewhere in France in 1944 of a Sherman tank climbing a muddy hill. The tracks are throwing arcs of wet earth into the air. The hull is caked with grime. The markings are obscured by dirt and damage. You cannot see the crew. You cannot see the gun. You cannot see the armor. But if you know what you are looking at, you can see the transmission. It is there, behind the heavy cast steel cover on the lower front hull, the rounded protrusion that gave the Sherman its distinctive bulldog face. Inside that cover, the gears are turning. The synchronizers are matching speed to speed. The oil is circulating through the cooler on the firewall, returning to the bearings at the temperature the engineers specified. The driver's left hand is on the shift lever. His right is on the steering brake. He is climbing a hill in second gear, the synchromesh holding the ratio steady, the torque flowing through the differential to the final drives to the sprockets that grip the track and pull 30 tons of steel upward through the mud. He does not think about the transmission. He does not think about the 6 companies that manufactured it. He does not think about the tractor engineer who designed the gear ratios, or the Buick machinist who cut the gears, or the Chrysler assembler who bolted the case together. He does not think about the German Panther that is parked 2 miles behind the front line with a broken final drive, waiting for a recovery vehicle that will not come because the recovery vehicle is also broken. He does not think of any of this. He shifts into third. The synchronizer engages, the gears mesh, the tank accelerates, the hill is behind him, the war is ahead, and the transmission, invisible, uncelebrated, built by car companies and tractor makers and 100 small subcontractors whose names history never recorded, carries him forward. He does not know that the Caterpillar engineer who designed those gear ratios spent years building transmissions for bulldozers that cleared forests and dug canals. He does not know that the women on the Chrysler assembly line who bolted his transmission together had never held a torque wrench before 1942. He does not know that the cast iron of his gearbox case was poured by a foundry worker in Michigan who drove a Buick to work every morning and never thought about the connection between the transmission in his car and the transmission in the tank his factory was building. He does not know any of this because the transmission does not ask to be known. It asks only to be used.
Today, the M1 Abrams tank that replaced the Sherman uses an automatic transmission, an AGT 1500 turbine engine coupled to an Allison X 1100-3B cross-drive transmission that handles shifting, steering, and braking in a single integrated unit. The driver has no clutch pedal.
He has no shift lever. He has a T-bar that controls speed and direction, and the computer inside the transmission does everything else. The philosophy that began with the Sherman synchromesh, make it so simple that any soldier can operate it, make it so reliable that it never fails when the soldier needs it most, reached its logical conclusion in a machine that removed the human from the shifting process entirely. But the M1's transmission traces its ancestry directly to the 5-speed gearbox that Caterpillar designed and Buick and Ford and Chrysler and Iowa transmission and Reed roller gear built by the hundreds of thousands. The philosophy is identical. The execution has simply caught up with the ambition. The Sherman's engineers wanted a transmission that any farm boy could drive. The Abrams engineers wanted a transmission that did not require a farm boy at all. Both succeeded. Both embodied the same truth that K.T. Keller discovered when he answered that telephone call in 1940. The best weapon is the one that works when you need it, every time, without exception, without drama, without asking anything of the operator except that he pointed in the right direction. 30 tons of steel, 5 gears forward, 1 reverse, brass synchronizers in a cast iron case bathed in 152 quarts of SAE 50 oil, designed by men who built tractors, manufactured by companies that made automobiles, operated by boys who learned to shift gears on their father's pickup truck, maintained by mechanics who learned their trade in gas stations and Chevrolet dealerships, proven across 3 continents in sand and mud and snow and the rubble of destroyed cities, over distances that would have destroyed any German tank that attempted them. And the only sound it made when everything was working as it should was no sound at all. That was the American weapon, not the gun, not the armor, the silence of a machine that worked, the silence of a gear engaging smoothly, of a synchronizer doing its job, of oil flowing to a bearing, of steel meshing with steel inside a case that was bolted shut in a factory in Detroit and never opened again until the war was over. The Germans built for brilliance, the Americans built for Tuesday morning. And Tuesday morning, repeated 50,000 times across the face of the earth, won the war.